Okay, this is section 6.5, solving equations containing rational expressions. So this is pretty much what we do when we're given an equation that is involving rational expressions. This is an example one right here. All three of these are rational expressions. Remember, even just a regular ordinary fraction is a rational expression, because a rational expression is a ratio of two polynomials. And for example, 3 is the constant polynomial that evaluates to 3 for all values of x in the domain, and 2 is the constant polynomial 2. So here are the steps we're always going to take. The first thing, I actually mentioned this twice because it's important, so I mention it both first and the very last thing. Take note of any values which make any of the denominators in the original equation equal to 0. Whatever values those are, they have to be excluded from any resulting solution set. So if the rational equation has any polynomial of degree 1 or higher, that means there's an x term, then you set each denominator equal to 0 and solve for x, and those values will be rejected. There isn't any in our very first example. Then we clear the denominators by multiplying both sides of the equation by the LCD. Well, we can do that. That's exactly what we're doing. Or we can just add them together, because that's what we've done before. As a matter of fact, if you've not realized it yet, when we're adding, my method I gave you for adding rational expressions is really just a method of clearing denominators in a way. So then we solve the resulting equation, and then we check to make sure any of those solutions we get at the end aren't solutions that are restricted from step number 1. So let's do our very first one. So we'll just do it in steps. There's not too many problems here. So our very first step, we'll find the LCD of 5 and 2 and 10. Well, let's go ahead and just a reminder of the table method. It's a really good method to use, and I may require you to use it on the next exam. If you use this method, then there's no question whatsoever that you're doing the work. So in this case, we have 3 values, 5, 2, and 10. So again, just using our table method here. So we have to find the prime factors. So that if there were polynomials, we would factor them. But in this case, I'll note 5 is prime. It can only be divided by 1 in itself. So 5 is one prime factor. 2 is also prime. It's only divisible by 2 in itself. And 10 is 2 times 5. And those prime factors are already there. So let's go. How many times is 5? So if you want to put over here, 10 is equal to 5 times 2. That may be helpful. How many times does the factor of 5 appear in 5? 1. How many factors does 2 appear in the factor 5? 0 times. How many times does 5 appear in 2? 0. How many times does 2 appear in its own factorization? 1. How many times does 5 appear in the prime factorization of 10? 1. And how many times does 2 appear? 1. So remember, for the LCD, what we do is we circle the largest value in each row, and the LCD is equal to our prime factor raised to the highest value. So it's equal to 10. So we did that. So now let's go down here and write our actual problem. 4x divided by 5 plus 3 divided by 2 is equal to 3x divided by 10. And here we literally multiply both sides by the same value. If we don't multiply them by the same value, then I break the equality. And that value is the LCD. So I went ahead and I skipped the part of our first step where we discover if there's any values that make the denominator 0 because our denominators are constant. So now all I do is simplify. 10 divided by 5 is 2. 2 times 4x is 8x. 10 divided by 2 is 5. 5 times plus 3 is plus 15. And here the 10s just cancel out. So this is really elementary to solve. 8x minus 3x is equal to minus 15. So that gives me 5x is equal to minus 15. So I divide both sides by 5. And that gives me x is equal to minus 3. And I'm done. So you've actually already been doing this type of problem way back, I think, in the very first or second chapter. So let's do one that isn't something you've done. So here, I'll go ahead and write it down. I have 3x minus, and here I have a minus. And what follows, the numerator is a sum. So I'm going to immediately enclose it in parentheses, so I don't make a subtraction error. So let's find the LCD of x, 3x, and 3. Well, I hope you're able to see this is just simply 3x. Why? Our prime factors are 3 and x, and remember our final LCD is the number of times the greatest number of times each factor appears. So it's going to be 3 to the first times x to the first, which is equal to 3x. And I'm seeing right now I got excited and went down to the table and didn't finish writing what I said. It's 3x. So I'm going to clear denominators. I'm done with that over here. So I'm going to put in parentheses, again, both sides, and I'm going to multiply both sides by 3x. So we're clearing denominators. Before I do that, again, sometimes it's easy to forget, let's find the values of x that will be restricted. So we said each denominator that is a polynomial equal to 0. So x is equal to 0, so 0 has to be excluded. If 3x is equal to 0, that implies x is equal to 0. So what I'll do is I'll put up here in my do not forget box, exclude x equals 0 from the solution set. Now, it may very well be that the solution set does not contain 0 in it, in which case there's nothing to exclude. I'm going to go ahead and I was going to erase all of this, but I wanted to get my stylus bigger. I've been having joint problems. I've been typing so much, so I got a new ergonomic keyboard it's a mechanical keyboard. Actually, it's a gaming keyboard. It looks pretty nifty, but I got it for its ergonomic abilities, and I'm still getting used to using it. So I've raised my laptop up on a stand, and I'm not using its keyboard. I'm using the ergonomic keyboard below. I don't know, for some reason I could not get, it doesn't matter. Let's just do it. So 3x divided by x is 3. So 3 times 3 is 9. I don't want to use 9. Red. It did make it bigger. See how much thicker that is? So now I kind of want to go down. So that's 9. 3x divided by x is 3. 3 times 3 is 9. And now my 3x divided by 3x is 1. So that's minus x plus 21. Notice how nice it is that it's in parentheses there. And over here, 3x divided by 3 leaves me x, so it's equal to 5x. So now this is just really nifty to solve. This is 9 minus x minus 21 is equal to 5x. So 9 minus 21 is minus 12. And I'm going to move the minus x over, so it becomes 5x plus x to get 6x. And then I simply just divide both sides by 6 to get minus 2 is equal to x. So I'll make a quick check up here. And minus 2 isn't any of the values I need to exclude, so I'm done. X is equal to minus 2. Now let's do the next one. Some of these can get involved, and this is going to be our first involved one. So it's nice here because we don't have to find the least common denominator. So we have x plus 6, because the denominators are the same, over x minus 2 is equal to 2 times x plus 2 over x minus 2. So I'll note that the LCD is equal to x minus 2. And really, once you find the LCD, once you know what it is, to find the values that have to be excluded, is you just set the LCD equal to 0. You don't have to set each individual denominator equal to 0, but just the LCD, and that works just as well. So x minus 2 equals to 0 implies x is equal to 2. So we have to exclude x equal to 2 from any solutions. So now all we do is we have our LCD as x minus 2. So I'm going to go ahead and put the entire thing in parentheses and multiply by x minus 2. This one actually is not involved at all. I'm looking at another page of my notes, the one, example 5. And notice that once I do that, the numerator and the denominator, the x minus 2's, cancel out. So that leaves me x plus 6 is equal to 2 times x plus 2. So that gives me x plus 6 is equal to 2 times x is 2x. 2 times 2 is 4. So I'm going to bring my x, my 4 I'm going to take over to the left-hand side, and it becomes negative. and my x I'm going to take to the right hand side, and it becomes negative. So I get 2 is equal to x. But right here, last step, I notice that x cannot be equal to 2. These are the values that it cannot be equal to. You can put a little slant through the x is not equal to 2 if you want to do that. So the final conclusion is that there is no solution to this particular problem. Okay, let's do another one. So this is example 4. So I have 2x, just do it right here, 2x over 2x minus 1. So this is plus 1 over x is equal to 1 over 2x minus 1. So we need to find the LCD of 2x minus 1 and x. Now 2x minus 1 is prime. It can't be factored. X is a variable. It's also considered prime. It can't be factored. So the LCD of 2 primes, I'll write this here, the LCD of 2 distinct primes, in this case they're prime polynomials, is just the product of both. So my LCD is equal to 2x minus 1 times x. So that's going to be my LCD, and I'm going to go ahead and get ready to multiply both sides by my LCD. Give me some room here. But I'm not going to do it until I actually find out the values that need to be excluded. So you leave them in their factored form. That's important. So the first thing we do, we have to find the exclusion part. So here's the exclusion part. So I'm going to set my LCD, which is equal to, if you need the exact 2x minus 1 times x. So you set the LCD equal to 0. So this is factored, so you just set each factor equal to 0, and that gives me that x is equal to 1/2, and then x is equal to 0. That gives me x is equal to 0. So the values excluded are x in the set, 0, and 1/2. So these are the excluded values. So coming back over here, let's go ahead and multiply through and clear denominators. 2x minus 1 times x divided by 2x minus 1 just leaves x. X times 2x is 2x squared. 2x minus 1 times x plus 1 over x. Well, x divided by x, the x's cancel out, so that just leaves me 2x minus 1 times 1. So it's plus 2x minus 1. And over here, the 2x minus 1 and the 2x minus 1 factors cancel. So the only thing I have here is x. So I have to solve this. And the only way to solve this is to factor. So I put it in the general form. By moving the x across the equal sign, it becomes negative. So that gives me 2x squared plus 2x minus x is plus x minus 1 is equal to 0. So now we have to factor. So let's do the factoring really fast. So I'm going to go ahead and do this the way we've been doing it. It goes really, really fast. It's not obvious what the factorization is at first, although some of you might be really good and you already know what it is. So 2x squared minus 1 and x. So this has to be 2x and x. And minus 1, one of these have to be negative. So I'm going to make that minus 1 and that 1. So that gives me 2x times 1 is 2x. X times minus 1 is minus x. 2x minus x is equal to x. So my factorization is, remember our kitty corner, I'm just going to do a kitty corner 1. So our kitty corner factorization is 2x minus 1 times x plus 1, and that's equal to 0. So now we're just solving a quadratic equation by factoring like we've done before. So I set 2x minus 1 equal to 0, and I've actually already done that over here. So I already know that that gives me x is equal to 1/2. And that's going to have to be excluded. And then x plus 1 equal to 0 implies x is equal to minus 1. So these are my two possible solutions. So always remember when you solve for x, these are possible solutions. But over here, we cannot have x equal to 1/2. So this one is excluded. And my final answer is just this. X is equal to minus. Sorry, the phone rang and I did not have it in the other room, so I need to start with number 5. So this is number 5. And the first thing we're going to do is we're going to simplify it. If there's any simplification that can be done, you need to do it. Now the first term, 2x over x minus 3, there's nothing that can be done to simplify that. 2x is prime, and so is x minus 3. But plus 6 minus 2x can be simplified because the greatest common factor is 2. So I can pull out a 2. 6 divided by 2 is 3. Minus 2x divided by 2 is minus 1. So that gives me minus x. And x squared minus 9 can be factored into x minus 3 times x plus 3. That's that all-important difference of squares factorization. Let's give me some more room over here. There's still some simplification that can be done. I want you to look and see if you can see what it is. It involves this term right here. Notice that 3 minus x and x minus 3 are really, really similar. If I could somehow change 3 minus x to be x minus 3 times some factor, I could cancel that factor out. So if you realize that 2 times 3 minus x is the same thing as 2 times minus 1 times x minus 3, then you got it. So that's what we're going to do, is we're going to replace my 2 times 3 minus x, let me kind of erase that there, with a minus, 2 times 1 is minus 2, with a minus 2 times x minus 3. So you need to review that. All I did is I factored out a minus 1. And what prompted me to do that? The similarity of 3 minus x and x minus 3. So this is x minus 3 times x plus 3, and that's equal to x over x plus 3. I'm going to go ahead and erase all of this down here. What is it doing? What? For some reason I can't get my stylus to get bigger. It's doing weird things on me. I just want to erase that. Can you just let me erase this? So while I'm erasing this, go ahead and see if you can't simplify this right here one more line. And it's actually really an easy simplification. Well, there's again nothing you can do with the 2x over x minus 3, but you can cancel out the x minus 3 factors. So that's going to give us minus 2 in the denominator and x plus 3 on the 2 in the numerator and x plus 3 in the denominator is equal to x over x plus 3. And that's going to be the form we're going to work with, is that form right there. So we need to find the LCD of x minus 3 and x plus 3. Again, both terms are prime, so the LCD is x minus 3 times x plus 3. And let's go ahead and see what I have to exclude. I take my LCD of terms and I set it equal to 0. X minus 3 times x plus 3 is equal to 0. You solve it by setting each factor equal to 0. So that gives me the values of x is equal to 3, or x is equal to minus 3. And just remember, these are values that have to be excluded in the case that one of our possible solutions is one or more of those values. So, as always, now that I have found the LCD, I multiply both sides by the LCD. And you always leave it factored. So that line right there means implies. I don't like having tons of equal signs. It gets confusing and becomes what is equal to what. So here we go. It's not going to be difficult. Notice that the x minus 3 terms cancel. So I'm again just using distribution here. X minus 3, x plus 3 times this, and then times that. So I get 2x times x plus 3, because the x minus 3 terms canceled. And then minus 2, and now my x plus 3 terms are going to cancel. And that's going to leave me x minus 3 is equal to, here my x plus 3 and my x plus 3 are going to cancel, is equal to x times x minus 3. Now I have to solve this. And you can do it many different ways, but I'm going to suggest we be really algebraic with it. And of course the way to solve it is I have to set everything equal to 0. So all of my terms with my x value are going to be on the left hand side. So I'm going to move this x times x minus 3 over. And and set it equal to 0. So now I'm going to show you something. Right here, I have a common factor of x minus 3. So I'm going to kind of just isolate this little segment right here, and I'm going to factor out the x minus 3. So I'm not doing anything to the first term. But here I have a plus x minus 3. And when I factor it out of these terms, I get a minus 2 minus x. And that's going to be equal to 0. So if you want to see what I just did, I'm going to come over here. Minus 2 times x minus 3 minus x times x minus 3 is equal to x minus 3 times minus 2 times x minus 3 divided by x minus 3 gives me minus 2. And minus x times x minus 3 divided by x minus 3 gives me minus x. So that's what I did. But I'm going to go ahead and I'm going to change some things around. And I'm going to pull out a negative here. So minus 2 minus x is equal to minus 2 plus x. So this is I'm going to factor out a negative. So this is going to become x minus 3 times minus 1 times 2 plus x is equal to 0. And here finally, the minus 1 is going to come out in front. I'm going to have x minus 3 times 2 plus x is equal to 0. So on this little step out here, starting right here at the yellow, you don't have to do this. I wanted to do it because it's literally the algebraic thing to do. As you get into more math, you've got to start looking for those types of patterns. But you could just go ahead right here at this step and multiply everything out and collect like terms and simplify. But we're going to go ahead. The reason I didn't want to do that is because there could have been some nice factorization that I ended up with at the end, and unfortunately I don't. You never can tell. So multiplying out, this is 2x squared plus 3 times 2x is 6x. And here, I'm going to multiply these out. This is x times 2 is 2x. X times x is plus x squared. Minus 3 times 2 is minus 6. And minus 3 times x is minus 3x. So I have 2x squared plus 6x minus 2x minus x squared plus 6 plus 3x is equal to 0. So let's collect like terms. 2x squared minus x squared. So my x squared terms have been taken care of. Let's do our plus 6x plus 3x minus 2x. My 3x, my minus 2x, and my 6x has been taken care of. Plus 6. Still in the simplification stage. But getting closer. 2x squared, I told you these can be involved. 2x squared minus x squared is x squared. 6x plus 3x is 9x, minus 2x is 7x. So this is really easy to factor, and you should see that the factorization, which you should do on your own, is x plus 1 times x plus 6, and that's equal to 0. So what do? We set each of the factors equal to 0. That implies x plus 1 is equal to 0, or x plus 6 is equal to 0. And this implies x is equal to minus 1, and this implies x is equal to minus 6. So recall, these are possible solutions. And thankfully, if we go back up and remind ourselves, the solutions that we had to exclude, if they were to appear in our possible solutions, is x is equal to 3 or x is equal to minus 3. And neither of our solutions are those two. So these are the solutions right here.